identify the functional requirements. And for the functional requirements, I'm just going to list them one at a time. So the first one would be to start a chat, because when you open WhatsApp, the first thing you see is a list of chats. So I'll say start a chat. Then you should be able to send a message. Then also you should be able to receive a message. In fact, let me put these two together. You should be able to send or receive a message, and not only a message, but messages. I think this is better. Then you should be able to also upload media or send media. And by media, I mean stuff like maybe a video you want to send, an image, audio, and the like. Then you should be able to see messages when offline. Then another one I can say is create or view a status. And of course, WhatsApp has grown to be very big. And there's so many features like communities. You should be able to create a community, for example, create a community. It has things like video calls, I'll say video or audio calls. And we can go on and list all of them. In fact, in an interview, I don't think you'd be expected to go through all the functional requirements, unless if there's really enough time, but there's barely enough time to go through and design and go through all the functional and non-functional requirements of a particular application that you're designing in an interview. So I'll design as many as I can in this video. Let me go on to the non-functional requirements. So to do that, I can simply copy this box. Let me try to copy it and then duplicate it. Did that work? That I think failed. Copy, duplicate. I think I'm now successful. Yeah, it's down here. Then I'll rename this to non-functional. But even before that, I can delete all this. Then say these are going to be the non-functional requirements. And I can just draw a line just below the titles for better visibility. Not that maybe I'm a good designer. No way. You can already see how terrible my handwriting is. But let's go ahead. For the non-functional requirements, the first one I would think of is that a system usually has a number of parts working together. So these parts should, anything happen to them, we want the faults that happen to be manageable, okay, to be managed by the system. So I'll say should be fault tolerant. Tolerant. I don't know if this is the correct spelling. Please, I think fault. Does fault have, I think it's like this. Correct me if I'm wrong. I see my autocomplete trying to correct me. Okay, I think that is it. Then we should guarantee delivery of messages. Sometimes my brain betrays me and decides to make me speak English, which I cannot type. Guarantee. Okay, I was the correct spelling. Please correct me in the chat in case I'm wrong. So should be fault tolerant because we have so many parts working together. We should guarantee that message is actually delivered. And WhatsApp has billions of users. And of course, ahead we're going to talk about the numbers. Okay. But for now, I want to just say billions. Okay. We shall specify the actual number of billions and estimate ahead. So because WhatsApp has billions of users, it should be able, not be able, but let me first delete this. I want to define this better. The best way would be to simply say high throughput, okay? We need high throughput because of the billions of users, okay? Billions of users. Then what other non-functional requirement comes to mind? What's happening here? Looks like I'm struggling with spellings today. Okay, then because this is a real-time kind of application, we want the application to deliver the messages with low latency. Well, let's start maybe, let's say 500 milliseconds. I think this is fair. Looks like I've spelled this wrongly. Okay, I'm going to ignore this spelling checker thing and just go ahead. So yeah, I think I can deal with this for now. Of course, the other thing that you can go into like security, okay? But I don't want to go into so many non-functional requirements. And this is a mistake some of us always make during interviews. You list so many requirements and you end up getting so tired in an interview. I think in an interview, actually, I would maybe tell the interviewer that if I have more time, I will discuss the following. In fact, I would simply even put a line here. Let me use a different color. And I say, maybe below here, okay? Maybe I will not deal with this for now, but if there's time and if you want me to, I can talk about security. Even for this other one here, okay? I can maybe put a line and say I'll deal with maybe this for now. So deal with 1 to 5 and maybe 1 to 4. Yeah, so do not get into the trap of listing out all functional requirements and trying to design your system around all the functional and non-functional requirements. You will break. So the best thing to do is to mention a number and say if there's time, I'll maybe talk about these others. Yeah, even then, trust me, it takes a lot of time. In your free time, try to list as many functional requirements of a chat app that you know, okay? And add as many as you know and try to design them. You will see that you're going to get tired, okay? And you need a break and continue later. But anyway, let's go on. So this is the first thing we have done. Next up, I want to look at, so I'll copy the same box because I want to use it for writing. The next thing I'm going to talk about is now the core entities. Say number 2, the core, say core entities. I should delete everything here like so. Okay, so I think this is clean. Okay, so this is the second thing we're doing, core entities. The first one was to define the requirements, and that involved defining the functional requirements of the chat app and also the non-functional requirements. So before we continue, this video is part of a playlist where I'm talking about everything you need to know to design systems. If things I talk about in this video seem strange on you, it's better that you watch the previous videos that come before this video. To see them, check the playlist in the description. I'll copy this. I can write the core entities right here. So for core entities, usually what I do, I think about nouns or names of things that we need to deal with in a system. And I usually look at the requirements to get that, especially the functional requirements. So the first noun I would say is a chat. We have a chat. I'll number these. So the first one is we have a chat. We have a message. We have, for example, what else comes to my mind? Wait, by the way, I've mentioned chat and message, but remember, who is creating the chat? Who is starting the chat? Who is sending the message? Who is receiving a message? It is the user or users. So it should have been the first. And of course, for WhatsApp, we can generalize it as users because it is not really specific. I know right now WhatsApp has things like admins and the different types of WhatsApp applications, okay? I want to just stick to the original WhatsApp, not these other variations of WhatsApp. Now, if you, of course, working with a tool like, not a tool, but designing an application like, which one can I give? I'm thinking about another application, creating a system for maybe musicians. You'd have maybe different types of users, like maybe the band director, bass guitar player, the alto player. Will be different types of users, and you might want to differentiate them. Maybe in like a taxi app, you'd have maybe a passenger, a driver, you get stuff like that. But here I'm just going to generalize as users because more or less you're doing the same thing of just chatting or sending and receiving messages. The other one, maybe I would say maybe clients. Okay. Client in this case, I would mean like a laptop, a phone, because when you own a WhatsApp account, you can use that account on other devices. In fact, up here in the requirements, I should have maybe put that should be able to access the chats on my devices. Yeah, but of course it's below the line. So if you want to do that, in fact, maybe I'll try to see if I can add it later when we are designing. So I don't know how I can squeeze it here. Let me squeeze it. I'll say 8 access chats on all, let me say on my devices. Okay. Later we shall talk about this. Maybe I'll hint on some of these things which are below the line. Okay. So of course, when you're designing a system, I feel like one should be free to go back and forth, okay, between the core entities, maybe the functional requirements, the high level design, and stuff like that. All right. Now I want to go into the next bit. So I'll duplicate this, and this will be the third. So for number 3, in this step-by-step process of designing, the chat system would be talking about just the API interface, communication, and commands. Okay. Yeah. So for communication, what would I choose? Okay. For communication, of course, because I know that we are dealing with a real-time chat application, I would go for a WebSocket. But why a WebSocket? It should be the question going on in your mind. And I'm going to just explain to you how I would arrive to using a WebSocket. The first question I would ask myself, is this application latency sensitive? So let me just copy this box down here. Okay, I'll say, is it latency? Can I spell this correctly? Is it latency sensitive? Okay. Is it? If it's latency sensitive, then I can think about something else, which is better. But if it's not, I'll go for a simple solution like polling. Okay. If you don't know what polling is, please look at the videos that come before this video in the playlist. I'll look at things like polling. If it was latency sensitive, okay, so think of this as like a flowchart. So this is I need this pen. So this is a no, and then the yes. So if it is latency sensitive, then I think about other solutions. For example, what could help with something that is latency sensitive? The first thing would be a technology that supports bi-directional communication. So say bi-directional, okay, communication. In fact, the best thing would be frequent, okay, frequent bi-directional communication would be the best, can I say, the best question to ask. This system requires very low latency. And if it requires very low latency, do we need frequent bidirectional communication? That's what comes to my mind. So if that's the case, then I look at other options, okay? If the answer is yes, then we might need things like WebSockets. You get a WebSocket could be the solution. If it's not, then we might need something like an SSE. An SSE simply stands for server sent events, whereby the server only pushes. It's a push only kind of communication, whereby the server sends events to the client, but the client cannot send back. So the client only receives from the server in a push only mechanism. Okay, so this is the no part of our flow, and this would be the yes. But even then, for a WebSocket, you may not have it as best solution. Why? What if, think about this, what if you needed peer-to-peer connection, whereby you need a connection which bypasses the server? Let me use the same format by simply copying this, duplicate it, and drag it down here. So what if what you need is actually a peer-to-peer kind of connection, whereby a client is communicating with another client by bypassing the server. Okay. This would be good for stuff like video calls, okay? But in our case, remember, it's below the line. So I wouldn't go to having a peer-to-peer network. But in case I needed that, if you need it, then you look at technologies like WebRTC. And better, on this channel, I have a playlist where I'm building a project end to end, and I implement server-sent events using Redis and using Kafka. So yeah, look at it. So for communication of this application, I am going to use WebSockets, whereby we shall have a full duplex bidirectional communication, okay, over a TCP connection. So I hope all this makes sense, okay? In case anything confuses you, please let me know in the comment section. All right, now let's move on to the commands. What commands do you think we are going to send over this WebSocket connection? So I'll come here and say the commands. For the commands, we need commands like, for example, usually before even giving these commands, when I'm thinking about my commands, I derive them from the functional requirements. So like here, start a chat, send a message, I would say create chat, okay? Create a chat. Then I'll have a command like send message, okay? Ideally, you have commands which deal with sending things, send commands, and also you have commands that deal with receiving. So if you need to send a message, you also need to receive a message. I already feel like this is going to take long. So maybe I need to be a little bit fast, but there's no need to be fast. Let me do as much as I can. If I get tired, then I'll stop. Then we have this sending the media. We need a command to maybe create attachments. Okay, create attachments. Can call them attachments or receive attachment also. Yeah, so create status. Okay, create status, view status. Okay, so ideally you think about the commands for sending and the commands for receiving. All right, so I think this is good enough for now. I want to move on to the next stage. So look at how I break this down step by step, okay? The function requirements, non-function requirements, the core entities, I derived them from the requirements. And like I told you, for core entities, simply think of them as nouns, okay? Or names of things that are going to be involved in your system. And then at the API, think about how your components, like the client and server, is going to communicate. What are they going to use for communication? Is it a REST API? Okay, by the way, for this, REST won't work. Okay, traditional REST won't work. Would it be REST? Why not? Okay, would it be polling? Would it be server-sent events? Would it be WebRTC WebSockets? So have this kind of framework I've showed you in your mind, whereby you go through a number of questions. You ask yourself, is it latency sensitive? Do we need bidirectional communication? Do we need peer-to-peer communication? Such things can help you decide what you need. Then, of course, the command is to satisfy each of the functional requirements across this WebSocket that we have chosen to go with. Now, next up is number 4, is where we now go into the high-level design, okay? Where everybody loves to shine. So for my high-level design, I like to start it simple, and I would love to hear from you in the comment section. How do you approach this kind of stuff, high-level design? And if you're enjoying this is the time to share this video and like and subscribe. So I'll then just expand this a little bit. I think this is okay. Now just underline it. All right, so the high-level design, I would have a simple box representing your client. This could be your phone, your laptop, whatever device you're using. Here, phones are Android devices, and you cannot refer to an iPhone as a phone. You say iPhone, not phone. Just like if you have a MacBook and you call it a laptop, to look like an insult. So just call it a Mac, not a laptop. Anyway, no need to go into that. Forgive me if I've disturbed you. All right, so we have our client, okay? We have the client here, and then we have a server. You can call this a chat server. And like I've told you, the chat server is connected to the client, or the client is connected to the chat server via a web socket. Okay, so at this point we have a single TCP connection. Follow me closely. I'm going to go step by step, and I'll identify a few challenges here and there and increase the complexity. In case anything confuses you, just let me know. I can do a very good follow-up video. So let's assume you wanted to perform this create chat. Okay, the request comes from the client to the chat server to create a chat, and the chat server performs operations or requests that make a write operation to our database. So I'll create this simple box here and I'll name it database. So database, and this database will be, I'll just go with DynamoDB. Why? Because yeah, it would perform efficiently for what we need, and I've been learning it, so I want to practice designing systems with it. Yeah, it's a very, very powerful thing. I have learned of it recently and I've liked DynamoDB. So, but of course, you can even use any key value store that you know of. You can even use a relational database, okay, if you want, like Postgres. And trust me, they can also scale. Now, once you're a client, okay, and you send your request across the WebSocket, and you want to create a chat, okay, so it goes to the chat server sends the request to the database to create that record. And in the database, ideally would have a chat table. And this chat table or chats table would have a unique ID storing the chats. And of course, a chat has a name. And maybe I would have another field for storing any other metadata that the chat has. Metadata, as simple as that. In fact, I want to drag all the things so that they are visible for you. Sorry, what am I doing? Let me see if this has worked. Okay, this is okay. So I can drag all this so that it is visible and place it around here. And then for every chat, remember when you're creating a chat, you also specify the participants. Would need to have a table for the chat participants. You need to get I think these are the boxes that are easier to use than drawing. Drawing using the cursor is kind of tedious. So I have another table called the chat participants. And I'll drag it so you can see it better. So chat participants table, and the chat participant table would have, of course, the chat ID, and then it would have also the participant ID, the chat participant ID. Can I just say participant ID? Participant, can I spell this? ID. And the goal here of these two tables would be to help us achieve two main things for now. When you want to get, let us say, participants for a particular chat ID or a particular chat, let's say a chat has an ID called, what example can I give? Maybe if the ID is maybe, let us say, XYZ, okay, as an example. And given this chat ID, you want to know all the people, okay, in that chat. Maybe there's user A, B, C, D, okay, number of users. What I would do is create a composite key, okay, using these two. And that would mean that the chat ID becomes a partition key, okay, in MongoDB, so that chats are located, okay, according to partitions. So that if you need a particular record, okay, you just go to that partition directly. Why? Because the data has been organized in terms of partitions, and these partitions are identified uniquely by this chat ID. So when you give me a chat ID, which is now called the partition key, by the way, this chat ID is the partition key, and the participant ID would be the sort key. So given one chat ID, we shall be able to find out all the participants of that chat. Then the other thing that we can do is the opposite by having something called a GSI. So GSI in DynamoDB world is Global Secondary Index, okay? And what simply it means is that it will help us to do the reverse. Remember, the first flow I just described was that given a chat ID, give us all the participants. What about the reverse? When you need participants, not participants, when you need the chats of a particular participant, what do? I'll explain this again. Given a chat ID, which is the first flow, give us all the participants of that chat. Then the reverse is, given a participant, tell us all the chats they are part of. Those are two different things. For example, if a user is called John, give us all the chats he's part of. Maybe he's part of maybe a football chat, okay? Or he's chatting with maybe the girlfriend Mary. I don't know, whatever chat they're part of, okay? Given this one participant, give us all the chats they're part of. So that would be the GSI helping us with that. And GSIs are very powerful because it helps you have like a view of your data without having to rearrange your database schema and the columns and rows in a particular way and do kind of, I don't know, wise querying. You don't need that. So look into GSIs and you'll see that MongoDB, not MongoDB, but DynamoDB is very, very interesting. All right. So I have done something, and if I go up here, there's a function requirement I have fulfilled. I think starting a chat has been fulfilled. Let's talk about receiving messages. If you were to receive a message, what would happen? And again, I'm going to improve this step by step. So to send a message, the client will send a message to the chat server. It would have a record by now of the chat and the chat participants. So this chat server would have a memory data structure. In this case, I'll use a hash map, whereby it will track the clients so that we can send to them the messages. So this would happen. A client, say a client A, sends a message through the chat server. The chat server goes to the database and finds out where is this message going to whom is it going to. Take note that this happens because the client is going to send a chat ID in the message they are sending. So we go to the database, and given this chat ID here, okay, we find out the participants. You get, we find out their participants. When we find out their participants, the chat server then looks up in its hash map and finds out this participant A, where are they connected? Which connection are they connected to? So this hash map is only responsible for tracking or storing the connections, and not just any kind of connection, but the WebSocket connection to which the clients are connected. So you shall have like client A is connected on maybe their connection this, and that client B or user B on this other connection, this user also on their own connection. So when this client sends a message, okay, through the chat server to the database, and that client in that message has said that this message is going to this particular chat ID, the server, okay, looks up the participants for that particular chat ID and then finds out where they are connected to, okay, finds out their WebSocket connections in the hash map and sends back those messages to them. Again, this looks like a very naive design, but I'm going to improve it as we go on. So that is how I would deal with sending messages. Okay. Now, what about this other part which says, where is it? Says send media, okay, see messages when offline, create and view status. Let me deal with those ones. So if, for example, I wanted to view the messages offline, right now, what we have cannot support that. You get. So what I would do is this. When a client sends a message to the chat server, and then the chat server handles the database operations, I would have another table. Okay. This table would be, this table would be responsible for storing the chat messages. So I'll duplicate this and drag it here and say messages. Here I would say maybe ID to identify every record uniquely. Then I will have here the chat ID, something like that, if you understand. So that we know that this message which has been sent is for a particular chat. And by the way, if you model your database differently, please let me know. I'm still a learner. I'm a learner of system design and I enjoy learning from anybody. So if you know a little bit more than me, please share that little that you know. I would really appreciate. This time we persist the messages to the messages table. In addition to that, I would then have another table down here called inbox. Let me edit this to inbox. And of course, the inbox would track the message ID. Now, listen to the flow. If someone is connected and is online, meaning they have a active WebSocket connection, and they send a message, okay, to the chat server finds out the participants, then the messages are saved to the messages table and the inbox table, okay, or only messages for now because they are active. And then that message is sent via the chat server to the client. The chat server simply looks at its internal hash map to see where this participant or where participants are connected and sends them the message. Now, once that is done, very good. The other flow would be in case the user is offline. If they were offline, what I would do this instead is to, first of all, okay, have it stored in the messages, but also in the inbox. Now, when you come back and you connect, okay, remember this message has been sent to you when you are offline. And maybe the inbox could probably make use of the participant ID. Okay, what do you think? To avoid maybe over joining, but of course you can join between the chat participant messages and this table. But to avoid joining, you can put here another column, okay, called the participant ID. But let me know what you think in the comment section. Why would you put a participant ID here and why not? Anyway, so once someone is offline, we store their message in the inbox. The next time they connect, we first load their messages from the inbox. And the chat server will look up into its internal hash map and deliver the messages to them. Once the client has received that message, they'll send another request to the chat server saying, we have received your message. And that process is called sending an ACK. Okay, ACK is short form for acknowledgement. Acknowledging or accepting that I have received the message. And then here in the inbox, we can delete them. Because also, you know, WhatsApp is a data sensitive application. Now, when we are done with that, the next thing to do would be to maybe improve it a little bit. But even before that, let me first go to the functional requirements. There could be something small I've forgotten. All right, let's continue. Let's continue. I'm seeing this is getting longer than usual. Let me see how much more I can do. But I must leave or end this video when I have done something really good and you've understood. So how would I deal with sending attachments or videos and media? That is possible, but there are a number of ways you can do it. One way is to send that file through the chat server, but that would be very, very heavy for the chat server. So what I would do instead, okay, would be to have the client send a request to the chat server that I want to upload. Then the chat server makes a request to an object storage tool like AWS S3. So here we have object storage. I feel like this stuff is not big enough to write what I want. So let me just delete this and say this is like, I'll put an example. In this case, it would be AWS S3. So after that, the client sends a request to the chat server saying, I want to upload something. Then the chat server get a pre-signed URL, okay, from AWS S3 or any other kind of object storage. And this URL, I'll call it, or rather, they are called pre-signed URLs. Or this is the best way to work with this kind of setup, according to what I think, okay? If you know something better, please let me know. So we shall get a pre-signed URL. And this is simply a type of URL which has authentication embedded to it and a time to live or a TTL. So if these things are new to you, again, watch the other videos in this playlist before this video. You'll understand a lot. So after that, the chat server sends that URL to the client. And then the client uploads whatever they want directly to the object storage. When they upload this stuff directly to the object storage, they get a link. Okay, they get a link. And this link, now the client can embed that link in their, what is it called, in their message. Okay, so next time they're sending a message to the chat server, they embed that link, the text, and maybe the chat ID. And that is how it works. Instead of sending the actual image to the chat server to store it in the database. So our database wouldn't be the best way to store that blob. All right, let's now go ahead. Let me look at the functional requirements once again. I think we've satisfied the number of them. Because of time, I want to look at, I will come back to this one here called create view status, and then maybe these other things like 6, 7, but let me go to the functional requirements. Now, for the functional requirements, actually, if you've understood how I've designed these other four, I mean, create view status will be very simple, trust me. It's not as hard as you think. All you need is a table here with the right foreign keys, and you'll be good to go. Okay, let's look at how I would scale this. Okay, of course, WhatsApp has lots of users. And maybe before that, I missed out on something, okay? Maybe talking about the numbers, how much data we shall be storing, okay? When dealing with messages. Because for the chats, of course, there can be many, but we shall always have way more messages in the messages table than in the chat table. That is an important detail. And right now, I'm not quite sure of the number of users WhatsApp has right now, but I think they could be having maybe 2 billion users per day. So if they have 2 billion users, and I'm looking at the worst case scenario that all of them are active, and maybe they are sending 100 messages per day, what would happen? What would happen if this occurred? Our current setup cannot, first of all, accommodate that kind of, can I say, large quantity of users and people sending messages every second, okay? One chat server would not be enough. So 2 billion users sending 100 messages per day would make these 200 billion messages. Tell me what you think. Then if each message was maybe 1 KB, 1 kilobyte, that would mean we have around 200 billion kilobytes. 200 billion kilobytes. I don't know if that is correct, which is around, I think, 200 terabytes. Okay, so this is just my estimate. And actually, I wanted to avoid talking about numbers right now because I've not yet dealt with it, but this is like how you can estimate the numbers. Later, I'm going to create a video and I'll put it before this video in the playlist so that people can, first of all, learn how to make these estimates of the numbers of any system. Okay, so now let's go to scaling, knowing that we are going to deal with billions of users. So the first thing I would do would be, of course, to create multiple instances of our chat server. And that introduces a problem, of course, that I'm sure you've already identified. So I would assume we have another chat server. Okay, so I'll say chat server. So I'm just drawing the second one to illustrate that we're going to have hundreds of chat servers or even thousands, depending on the number of requests that we have per minute. Maybe let's say maybe per minute to having around, I don't know, 1 million requests. We need lots of chat servers. And of course, when you have hundreds and thousands of chat servers, we would need to balance the load. I would then introduce a load balancer here. Maybe let me use a different color. I would introduce a load balancer right here. Okay, I'll call it LB. And this load balancer would be a layer 4 load balancer, not a layer 7 load balancer. Why? Because a layer 7 load balancer will have to terminate the contents of the request. And that alone spoils everything, okay? Because these layer 7s are good at, or they're used for stateless kind of load balancing work, okay? And that termination of the current request and looking at its content is already creating more latency and is breaking the persistent connection that we need. A layer 4 load balancer works at the transport layer, and at this transport layer is where we have the TCP. that I talked about in detail in the previous video. So check out the video on protocols if you don't know what TCP is. So basically TCP and UDP run on this transport layer. And on this transport layer is where we don't terminate the request, okay? And because of this, it will help us to maintain the state, okay? So this load balancer will kind of be like invisible to our chat server. We shall have the connection maintained, okay? It will be persistent between the client to the server. You get, that's a good advantage of using a layer 4 load balancer. Always remember the type of load balancer you're going to use matters, okay? Is it a layer 4? Is it a layer 7? I'm sure many of you now understand why I talked about this before this video. Now, what algorithm would I use? I would use the least connections algorithm so that the servers which are heavy with traffic are not burdened, and those which don't have a lot of traffic are given work to do. Then after that, I would look at something else. When I'm designing systems, I like thinking about single points of failures. This load balance would be a single point of failure. And in the previous videos in this playlist, I talked about how you'd handle a single point of failure as a load balancer, or when a load balancer is a single point of failure. In this case, I would have two options: to set up two load balancers in an active state or active passive state or setup. In this case, I'll go for the active state, okay, because I would want no downtime, okay, because for the active passive, you have a little bit of downtime because once this one stops sending heartbeats to this other one, then this one can take some time to start. So I'll go for the active setup of the load balancer. So for now, I'll just have two, okay, just to have some kind of like failover mechanism. Okay, so that in case one load balancer goes down, we have another, and I can replace the other one. So this is what I would do. And again, if layer 4, layer 7, active passive is confusing you, failover is confusing you, check the previous videos in this playlist. And if you're watching up to this point, I'm sure you love this. So share, subscribe, and like this video. Then after that, I want to share another challenge that we introduced by increasing the number of chat servers, which is the storage. Remember, this initial chat server had a hash map, which was storing the connections, or it was responsible for tracking where is this client connected to. So in this setup, if, for example, a client sends a message, the chat server, and the records in the database are made, but now when sending back the message, the chat server may not have the record of where the participants are connected to. So it may not deliver the messages to the correct participants, or may not have them, because the hash map in this server may be different from the one in this server. So the best thing to do here, what I would do is this. When a client sends a message to the chat server, what I would do is use Redis. I want another color. So I'd come here, just write this and say this is Redis. And Redis has something very powerful. It's called Redis pub sub. Publish and subscribe. So when a client connects the chat server, would have a topic in Redis, and this topic would be a string whose value is the client or the user, not all their details, okay, but only their user ID. So a topic based on the user ID, so that the next time when, well, not the next time, but when we now want to deliver a message to participants, the chat servers don't have to store those hash maps, okay? They have a central place where they can find out connections. So this Redis here will do this for us, that when a client sends a message to the chat server, that particular chat server publishes that message to the topic. And all participants, okay, for that particular chat are going to receive that message because they have subscribed to this Redis feature. So let me do this and explain to you this better. Sometimes explaining these things can be a bit tricky. So to make it easy is this: all participants of a chat are subscribers you get of this stuff, okay, of this Redis pub sub feature. And so a message can be published to Redis, you get, and that message is delivered to each of the subscribers. As simple as that. Now, how would this be done to be better? Follow me closely. Again, if you're finding this complex, you may have to watch the videos that come before this video or leave a comment in the comment section and I will address your question. Our challenge was with the chat servers, having to know where the other users are connected to, or rather, which chat server is the user receiving this message or the users receiving this message connected to. So something comes to mind, which is, I can say is better, okay? But please feel free to share with me your own idea. Once a client connects for the first time, they register a subscription to Redis PubSub for that particular user ID. Now, when a message needs to be sent to that user, the original server, which was the one beginning this whole process, publishes what I can call a notification, okay, to that particular topic in Redis. And then Redis will take care of routing that message to the chat server to which that user is connected to. As simple as that. So Redis will be kind of like a tool that just simply registers topics, okay, and these topics are simply tied or identify particular user IDs. And then once anything is published to that topic or for that particular user ID, then that message which has been published is simply routed to users, okay, to the servers to which they are connected. Remember, these connections are WebSocket connections. So think about Redis PubSub as our new tool that is now keeping track of where people are connected. Okay, and trust me, it is very, very fast. Now, I have a question for you. In the event that Redis goes down as a single point of failure, how would you solve this? Try to think about it. In case maybe you created a Redis cluster, your chat servers might have to be connected to every node in the Redis cluster. That's another challenge. So how would you go about solving it? Leave it in the comment section. Now, what else can I talk about? So you see, designing systems is not quite easy. And like you'll hear many senior engineers say, there's not quite perfect system design. Many times it's all about choosing things or trade-offs. And okay, let me first go back here and see if there's something else I can talk about. So I think we've dealt with so many of these. How would you deal with encryption in case we were to do encryption or video calls? I think I'll leave this for now because I'm going to touch them when I'm trying to design video specific applications or applications which are based around only security and hashing and encryption. That will come in other videos when I'm designing similar systems. But leave a comment and tell me how you interact with these kind of things. Even this, I had something here. Where is it? Okay, this thing of clients. In case a user had many clients, okay, maybe like a phone, tablet, you see there would be a lot of data, okay? Not data, but a lot of stuff. Yeah, actually data, because what I would do in that case would be to introduce another table, okay? And I would call this table a clients table. Use something better. I would have a clients table. And this clients table would track the devices to which users are connected to, which means once a message is being saved, we now also save to the client table in the inbox, okay? When we are tracking, for example, like the recipients or participants, instead of now having an inbox for participants, we shall have an inbox for the clients. You get? We have here the clients. And that would also apply to this table here, the clients. This would be now instead client ID. Or not, depending on how you want to design it. Again, I want to cause you to think, would putting here client ID be good or bad? And why? Let me know. But for now, I would have another table tracking the clients so that this time when I'm sending messages, I send to the client devices. And I would want to have a limit, maybe say you can have a maximum of maybe 2, just say 3, okay, to be fair, 3 devices. You can't have more than 3, but I think WhatsApp has maybe like 5. I'm not sure, but for my case on my WhatsApp, I have more than 3, I'm sure, devices linked together. So this is how I would design WhatsApp. There is much more, but let me just leave it at this. And you can tell it's quite a tedious task. And I think if we were in a real interview, it would be much easier, because in an interview, I would be discussing with whoever is interviewing me. And I'm sure they wouldn't be working to fail me, but working to help me design something good. We'll be designing it together. And I'm sure, yeah, people will give you hints, and it would be like a conversation where you would be able to much more efficiently design something. Yeah, so there are much more things that we could do. Let me see. All right, let me just leave it at this. I hope this video has added some knowledge to you, and my thought process hasn't been so complex, and you've understood how I think, how I look at things. Yeah, but it's how I would approach it. I'm a person who learns daily, so if you design something better than this, please let me know. If you have something in a component, anything, okay, please let me know. And of course, I went into the high level design and deep dive at the same time. Usually when I'm talking about high level designs, I leave it at that. Then I go into the deep dive when I'm maybe dealing with the non-functional requirements, which need us to consider scaling, high throughput, low latency. But yeah, I forgot to tell you that, and I went straight into it. So take note of that. Usually without scaling, that would be your high level design, but then your deep dive will now be in a different section whereby you now go into like adding the load balancer, the Redis pub sub, maybe sharding and tools, techniques like that, okay? Depending on what you're designing. And of course, like I've said, it depends on the system you're designing. It's all about trade-offs. And in an interview, you'd have to have this smooth conversation to be able to understand each other. Anyway, subscribe, like, share, and I'll see you in the next video.